Hello, everybody. This is Shankar from SystemBaseLabs. Welcome back to the course From Models to Autonomous Enterprise Systems. Now, in our previous session, we explored the deep learning breakthrough. We discussed how artificial intelligence evolved beyond traditional machine learning systems. And we examined one of the most important transitions in AI history, machines beginning to learn representations automatically. But today we go much deeper because now we are entering the internal architecture of neural intelligence itself. Today we are talking about neural networks and representation hierarchies. Now let me ask you something. When humans observe the world, do we understand everything instantly in one step? No. Human cognition itself works in layers. You first recognize shapes, then patterns, then relationships, then meaning, and eventually context. Very important insight. Human intelligence is hierarchical, and neural networks evolved in a very similar direction. Now, earlier machine learning systems were relatively shallow. They learned limited relationships, but neural architectures introduced layered representation systems. Now, let us simplify this practically. Suppose a neural network is trying to recognize a face. The first layer may detect edges, simple lines, basic contrasts. The next layer may recognize curves and textures. Another layer may identify eyes, nose structures, and facial shapes. The deeper layers begin recognizing identity, expression, emotion, and contextual relationships. Now pause there for a moment. Think carefully about what just happened architecturally. The system is not merely memorizing images. It is building internal representation hierarchies, layer by layer, abstraction by abstraction. This became one of the biggest breakthroughs in artificial intelligence because intelligence stopped being shallow pattern recognition and started becoming hierarchical representation learning. Now, this is exactly why the word deep exists in deep learning. It does not simply mean large, it means multiple representation layers. Very important distinction. Now, another important thing happened here. Earlier AI systems depended heavily on handcrafted intelligence. Humans selected features manually, but neural networks began discovering representations independently. And this changed AI forever because machines started learning what matters without humans explicitly defining every rule. Now, from an enterprise perspective, this dramatically expanded AI capabilities. Computer vision systems improved rapidly. Speech systems became more accurate. Language understanding accelerated. Behavioral intelligence systems matured. Recommendation systems became context aware. And eventually, modern AI cognition architectures started emerging. Now, let us go one level deeper. Representation hierarchies also enabled abstraction. This is critical because real intelligence is not merely recognizing raw data, it is understanding relationships between concepts. For example, when humans see a chair, we do not analyze every pixel individually. Our brain already understands the abstract concept of chair. Neural systems started moving towards similar abstraction capabilities, not through human understanding, but increasingly powerful representation abstraction. And that changed operational AI dramatically. Now, another important architectural insight. As neural layers increased, models became more powerful, but they also became more computationally expensive. Training complexity exploded, data requirements increased, GPU infrastructure became essential, and explainability became more difficult. Because once representations become deeply layered, understanding exactly how the system reached conclusions becomes harder. This is one of the reasons modern AI systems are often called black box systems. Now, this introduced major enterprise concerns: trust, governance, bias amplification, operational explainability, model accountability, very important operational realities. Now, another major breakthrough emerged from representation hierarchies: transfer learning. This became revolutionary because once neural systems learned generalized representations, that knowledge could be reused across multiple tasks. For example, vision systems trained on millions of images could later support medical imaging, industrial inspection, autonomous systems, facial recognition, security analytics, and intelligent robotics. This dramatically accelerated enterprise AI adoption globally. Now, before we close, I want you to remember one important insight. Neural networks did not simply improve prediction, they transformed how machines internally represent reality. And representation hierarchies became one of the foundational pillars of modern AI cognition. Now, in our next session, we continue Module 3, Video 3 of 6, Class 15, Computer Vision and CNN Architectures, where we will explore how machines started learning visual perception and how convolutional neural networks transformed machine vision forever. Thank you, everybody. This is Shankar from SystemBaseLabs, engineering the future of intelligence together.